Hi there and welcome to Code Framer. So from this video we will start understanding about all the design patterns. So first we will start with creational patterns where we will understand about the builder patterns. Now when it comes to creational patterns in general, they basically handle the object creation process. Now when it comes to object creation process, it seems something very simple, but sometimes your object could be very complex, and to basically initialize an object or instantiate an object can be a daunting task because there could be numerous parameters which you will have to pass in order to create a particular complex object. So in order to handle such conditions where you have to basically create an object which is extremely complex in nature, we use the creational patterns. So in creational patterns, we will start with understanding about the builder pattern. So whenever we are trying to learn any new concept in this channel, the first question that we always ask is why. So which means that the first thing that we need to ask about builder pattern is that why is builder pattern required on the first place. So the main motivation for this particular design pattern, which is the builder design pattern, is simply that sometimes some objects can be extremely complex to create, which means that those objects can have monstrous constructors with lots of parameters, and most of the times for such complex objects, passing all the parameters in order to create an object can be a daunting task. So the builder design pattern is mainly used when we need to create a complex object that requires laborious step-by-step initialization of many fields and nested objects. So which means that sometimes in order to create certain objects, you may need certain nested objects as well. And along with those nested objects, you may have lot of parameters to give in order to create a particular object. So in such cases, you could imagine how our init method inside our class will look if we provide lot of parameters and nested objects as the input argument to that init method. So to solve this kind of a problem, we use the builder design pattern. And using this builder design pattern, we can basically segregate the process of creation of the objects from the main class to another class, which will be a builder class. So by doing this, you can basically give the responsibility of creating an object of a particular class to another class. And by this, you can simplify the process of creating the instance of a complex object. And we will see how we can do this in our example. So as far as the motivation is concerned for the builder design pattern, it is simply that sometimes creation of a complex object is a daunting task. And in order to make that process simplified, we can use the builder design pattern. So now after having understood the motivation behind this particular design pattern, now let us see what are the advantages and disadvantages of using the builder design pattern. So the first advantage of using the builder design pattern is that you can construct objects in a step-by-step process. So usually when we create an object from a class, we can simply call the constructor method of that class, right? But when it comes to using the builder design pattern, we can construct a class step by step, and we can construct a class as per our requirement. So this is the first advantage of using the builder design pattern. The second advantage is that you can reuse the same constructor code when you are building different representation of the same product. And we will see what it means in our example. And the third advantage of using the builder design pattern is that it follows the single responsibility principle. So as I said, that the responsibility of creation of the object can be given to a separate class. And by doing this, we can basically simplify the process of creation of an object. So these were the advantages of the builder design pattern. Now the only disadvantage that you will have by using this particular design pattern is that the overall complexity of the code increases slightly. Since this particular pattern requires creating multiple new classes, right? So you will have to create new builder class in order to basically segregate the responsibility of the creation of the object. You need to create a separate builder class, and that's why the complexity of your code slightly increases. But when it comes to the advantages, they are far more valuable than the disadvantage itself. But yes, as far as the disadvantage is concerned, following this particular design pattern will increase the complexity of your overall code. Now after having understood all the advantages and disadvantages of using this particular design pattern, now let us see what are the different components using which we can use this particular design pattern. So the first component is the builder, then we have the concrete builder, then we have the director, and finally we have the product. Now explaining about these components without showing you the example is going to be fruitless. So for now, now I just want you to know that these are the components, and we will see all these components one by one in our example section in this video. So before we start having a look at the example, just know the definition of this particular builder design pattern. So the intent of the builder design pattern is to separate the construction of a complex object from its representation, and by doing that, the same construction process can create different representations. So don't worry if it is not making sense right now. Now let us jump into the editor and start coding our example. So I'll give two examples in this video. The first example, we will simply concentrate on understanding this particular design pattern. So it will be a very simple example, because first we need to understand what this particular builder design pattern means, and after that, in the second example, we will just code each and every component that we just saw in this design pattern one by one, and we will build the builder design pattern in order to create complex objects. But that is something we will have a look on our second example. But first, let us just focus on understanding this particular builder design pattern. So as part of our first example, let us say that you want to create objects for different laptops. Now when it comes to creation of an object, you could imagine that there are many specifications that you can store in the object of different laptops, right? There are so many specifications like screen size, RAM size, type of storage, display information, hard disk information, model number, warranty period, and there are so many other information that you can basically store when it comes to creating an object of a laptop. But in our example, we will just use three specifications. Say for example, we will go for the brand name, and then we will go for the storage type, and maybe we can store RAM size. So let us quickly create a class as laptop, and then we can simply write our init method. So inside this init method, we can declare three instance variables. So we can write self dot. So the first information that we wanted to store was our brand name. So we can write self dot brand name, and we can give the value as none. And then we can store the information about storage type, and finally we can store the information about the RAM size. So initially we are just declaring all these values as none inside the class laptop, and let us write one more method which will basically show us the specification that we have stored in a particular laptop. So we can say def specification, and then we can just return an f string where we can just say that the laptop is having brand name as, and then we can write self dot brand name if self dot brand name, else we can say NA, not applicable. And then we can give a second line, and we can say with storage type, and then we can write the storage type. So self dot storage type if self dot storage type, else we can simply return NA. And finally we can have one last f string for the RAM size. So we can write f, and we can write with RAM size as self dot RAM size if self dot RAM size, else this can also be not applicable. Let us just ensure that the spacing will be correct. So here we can just add plus an empty string just to ensure that in our output all the sentences are having the right space. So this will have the right space, and also let us give one space to these not applicable so that the next sentence and the first sentence have at least one space between them. So this will be our output of this particular laptop object. So once we have stored all these information, this is how our output will look like for a particular laptop object. So you can call this class as the entity class, right? So for this class, we are going to create the object. Now you could expect that since we are storing only these three information, we could have simply taken these information inside this init method, and we could have just stored all of those information inside these instance variables, right? That could have been a simple thing to do. But again, remember that we are understanding about this particular builder design pattern, and you should imagine that this particular class is very simple in nature, but when it comes to complex objects, you could expect more than 30 parameters in this particular init method itself. And also some of those parameters may need creation of other objects. So which means that as part of the construction of this particular laptop object, you would need certain other objects as well, which must be part of this particular init method. So in order to create such complex objects, we need to use the builder design pattern. But when it comes to this example, I'm going with a very simple example, so you could focus on the design pattern alone. So now let us create our laptop builder class. So we can write class laptop builder, and inside this we can declare our init method. And inside this init method, what we will do is we will take the laptop object as the input argument, and if for some reason if you have not provided the laptop object as the input to this particular class, then we can simply create a new instance of the class, and then we can use that to create all the information. So if you pass a laptop object, then it will use that particular object that you have passed. But if you have not passed any laptop object and you have have called the laptop builder class, then in that case, the constructor of the laptop builder class will create a new laptop instance, and then it will use that particular laptop object to store all the attributes like brand name, storage type, and RAM size. So I hope that it is clear. So here we can simply write self.laptop, which is equal to the laptop. So this will be our init method for our builder class. So now let us write all our set methods, because using this particular laptop builder class, we want to create the object of the laptop class, right? Which means that in our laptop class, we have these three instance variables, right? Where we have to store the data. So here we can create separate methods for all these instance variables, which is there in our laptop class, in order to store those information. So we can write def set brand name, and we can take the name as the argument, and then we can write self.laptop.brand name is equal to the name, and then we can return the self. Now you must be wondering that why are we returning self here? The reason for that is when you have called the laptop builder class in order to create an object from this particular class, you will have access to all the methods that you are creating in this particular class, right? In your laptop builder class. Now when you are creating an object, you would want to access all those methods one by one in order to add the information that you want to add in the particular laptop object. And now since you are returning self here, now what happens is when this particular method has been called and the name has been set in your laptop object, then again this method will return the laptop builder object only, which means that using that particular returned object, you can again call the next method of the laptop builder class. And by doing this, you can basically chain all the methods together in order to pass different values that you want to store in your laptop object. Now if it is not making sense, then bear with me for some more moments, because we will be doing that coding in a short while. So let us continue to create the next two methods, which is to store the storage type and RAM size. So we can write def set storage type, and then let us say we take type as the input argument, and then we can write self.laptop.storage type is equals to type, and again we can just return self here. And let us now write the last set method, which is def set RAM size, and here we can take size as the input argument, and then we can write self.laptop.RAM size equals to size, and then we can simply return self. So after having written all our set methods, the final method that we have to write is the build method. So in order to write our build method, we can write def build, and then you can simply return the self.laptop. Now notice here that you have created this builder class, and here you can perform the creation of your object in a step-by-step process. So say for example, you create this builder object, which is nothing but the laptop builder object, and after that first you want to set the name or the brand name of your laptop, and then you want to set the storage type of your laptop, and then you want to set the RAM size of your laptop. And after setting all these attributes inside the laptop object, now you want to finally build the laptop object. So you can call all these methods one by one in order to create your laptop object. So now I hope that you understand how by using the builder design pattern, we can create the object in a step-by-step process. So now let us see how it is done. So first we can create the object of our laptop builder class. So we can say lb equals laptop builder, and we can just call this particular class. And now let us first just create our laptop object. Let us not give any brand name or any storage type or any RAM size. Let us simply create the laptop object. So we can write lb dot build. So this method will basically create the laptop object for us. Let us store this particular object inside a variable called laptop. So laptop equals lb dot build. So this particular object will now have the laptop object for us. So we can call the specification method which we have written inside our laptop object in order to see the output, right? So we can write laptop, or we can say print, and inside that we can write laptop dot specification. So as you could see here that in order to create the object of our laptop class, we did not even invoke the laptop class directly, right? We just invoked the laptop builder class where we instantiated that particular class and stored it into our lb variable, and using that particular laptop builder object, we were able to access the build method, and using that build method, we were able to create the object of our laptop class, right? And finally, with our laptop object, we are able to access the specification method using which we are going to see different specification of this particular laptop. So initially we have not stored any data inside our laptop. So let us see what output we get. So if we execute this particular code, okay, so we are getting some error. I think the error is related to these single quotes. It should be double quotes. Let us give double quotes here and let us give double quotes here as well. So I think now we don't have any ID errors. Now everything seems to be fine. So let us execute the code. So as you can see here that we are getting the output and it says that the laptop is having brand name as not applicable, and also the storage type and also the RAM size are also not applicable, because of course we have not given any data to the laptop, right? We have simply created the laptop object without providing any data, and that is why you have all the not applicables here. So now let us pass some information into our laptop builder class in order to construct the object with certain data of the laptop, right? So we can say lb.set brand name, and inside the brand name let us say we give Apple. So now as you can see that we have called the first method, which is set brand name, and after this we can chain all the methods, and this is the reason why we wrote return self in our laptop builder in all those set methods, right? Because here the set brand name method will return the laptop builder object itself. So which means that I can simply access the next method of the laptop builder class, which is nothing but, say for example, I want to store the storage type. So I can simply call that particular method, and let's say we want to give SDD as the type of storage, and then again we can call the next method where we can store the RAM size. So let's say the RAM size is 8 GB. So as you can see here that we have chained all the methods together, and this is the benefit of using the builder design pattern, because as you can see here that the process of creation of an object becomes so simple. You could simply chain all the methods that are available inside your builder class and you can create an object easily. So now after having given all these attributes, let us again print the laptop specification, which is to access the specification method of our laptop object. So if we execute this now, and as you can see here that the information that we provided are stored inside the laptop object. So it says the laptop is having brand name as Apple with storage type as SDD and with the RAM size as 8 GB. So now since the creation of the laptop object is handled by our laptop builder class, you don't really have to worry about the order of the argument that you are passing or the number of arguments that you are passing. Now say for example, if I remove set storage type from this and then if we execute this code, then as you can see here that the storage type becomes not applicable, but the remaining two specifications about this particular laptop are stored inside our object, which means that you don't have to bother about the order of the argument that you are passing, and also you don't have to bother about the number of arguments that you are passing. So following the builder design pattern gives you complete flexibility when it comes to creation of any complex objects. So I hope that now you are able to understand the advantage of using the builder design pattern and how it basically helps to create objects easily. So now let us have a look at the second example. Okay, so let us continue to code our next example where we will create the complex object using all the components of the builder design pattern. So if you remember in the start, we saw that there are 4 different components using which you can construct this particular builder design pattern, or you can basically construct a builder which can eventually create complex objects. So those 4 components were, the first one was the builder, which will be like an interface, and then we had the concrete builder, and then we had the director, and finally we had the product. So these were the 4 components using which we can basically design our builder in order to create complex objects. So having said that, in this particular example, we will continue to use the same example that we used for the first example, which was to basically create different laptops. So when it comes to laptop, you could imagine that there are so many companies out there who are manufacturing different laptops, right? And also each laptop has different specifications. So when it comes to a single company, like say for example HP, you will get a laptop with different specifications because each particular laptop will have different model numbers, right? So different models of laptop will have different specifications. And similarly, if you purchase a Dell laptop, again there also you will have different models of laptops, right, with different specifications. So now let us say that you want to create a builder which can basically create different laptop objects. Now you could imagine that when it comes to a laptop object, it could be a really complex object because you have so many specifications, right, in order to store for a laptop record. So in that case, if you do not use any builder and directly create a class for a laptop, then you could imagine that you have to store so many different values to create one object of a single laptop. So in order to solve this, we will follow this builder design pattern. So just to keep our example very simple, let us say that you want to create a laptop with only 3 specifications. So those 3 specifications will be the screen size of your laptop, then let us say we can have the processor of the laptop, and then we can maybe have the storage type again. So these are the 3 specifications which we will store for each laptop that we are going to create. Now before we start to code, just remember that you are building a general interface or a builder interface to create laptop of any brand. Now different companies will have different laptops with different specifications, but first you will create a builder which can basically build any laptop for you, and using that builder we will create concrete builders, and those concrete builders will be specific to different brands so that different brands can use those concrete builders in order to create their own specific laptops. So this is what we are going to do. So let us see how it is done. So first let us just create three classes for the three specifications that we are trying to store. So let us say class, and we can name it screen size, and in the init method let us take screen size as the input, and then we can simply store that inside an instance variable. So we can say self.screenSize, and then we can give screen size. Now let us create the next specification, which was to store the processor. So we can say class processor, and inside it we can create our init method where we will take the processor as the input, and then again we can store inside a instance variable, and finally we can create a class for the storage type, and inside again our init method we will take storage type as the input, and then we can again store this storage type into an instance variable. So we can write self.storage type, and that will be equal to storage type. Okay, so these are the three specifications that we want to store for each laptop. Now let us create the class for the laptop, and this will be the object which we would need whenever we are trying to create an object. So this is the final product for you, and this is the class which creates the product component for your builder. So if you remember that one of the component in our builder design pattern was the product, right? So this is the product. So we can write class, and since we want the laptop, so we can just name this class as laptop, and in the init method what we can do is we can just create three different instance variables, and we can just give none as the initial value. So we can say self.screenSize is equal to none, and then we can write self.processor is equal to none, and then we can write self.storage type is equal to none. And also let us create a specification method which can basically help us to see the different specification of any particular laptop. So we can write def specification, and we can simply return an f string where we can write screen size is, and then we can just write self.screenSize plus an empty space so that every sentence can have some space between them. If self.screenSize, else we can just give not applicable, and we can give some space, and then we can give the next line. In the next line again we can just write processor is, again we can just say self.processor with some space. If self.processor, else again we can give not applicable, and finally the last specification which is f, and inside that we can write storage type is, and then we can write self.storage type with some space again. If self.storage type, else not applicable, and then again we can give a space. So this will be our specification method using which we can see what are the different specification of our laptop, right? So this is the product component of our builder design pattern. Now let us create the builder itself, which will be nothing but an interface for us. So we can create it like a abstract class. So in order to create an abstract class, we always import the ABC module, right? So let us first import that module. So we can say from ABC import ABC, and also we can import the abstract method. The reason why we are creating an interface builder is because you want to create a general interface or a general builder which will be a laptop builder, using which different brands can use that particular laptop builder in order to create their own laptop builders, and using those brand specific laptop builders they can create their own laptops objects. So you could imagine that you are creating a general laptop builder using which different brands will create their own specific or brand specific laptop builders, and using those brand specific laptop builders at the end they will be able to create their own brand specific laptops, which is nothing but brand specific product, right? So in order to create this particular builder interface we can write class, and let us name this builder as iLaptop builder. Since this is going to be like an interface laptop builder, so we can say iLaptop builder, and we can simply inherit the ABC module in order to just declare this particular class as an abstract class. And inside this let us declare all the methods or all the specifications that we would want each brand to use in order to create their own brand specific laptop builders, right? So first one will be def set screen size, because these are the specifications that they will have to give, right? So we can write set screen size, and later they can basically override this particular method when they will be inheriting this particular interface builder into their own brand specific laptop builders, then they could simply implement these methods, and then we can simply write pass. Sorry, I forgot to mention abstract method, because inside an abstract class you should always declare abstract methods. Yes, you can declare concrete methods as well, but in order to create an interface, all your methods inside an abstract class should be abstract methods only. So whenever you are creating interface in Python, always remember that all the methods inside your abstract class must always be abstract methods, because when it comes to Python, there is no concept called interface as such. Like how we have in Java, we don't have similar concept in Python. So when it comes to Python, what we can do is we can just inherit the ABC module in order to declare a particular class as abstract class, and then we can create all the methods inside that abstract class as abstract methods, and then that particular class can act as an interface in Python. So I hope that that is clear. So the second method will be abstract method, and this one we can name as set processor, and again we can just write pass, and then the next method will be def set storage type, and again we can just mention pass. And finally, don't forget, whenever you are creating a builder, you need the build method. So again you can create one more abstract method, and inside that you can write def build, and again you can just simply mention pass here. So this will be our laptop builder interface, using which different brands can create their own brand specific laptop builders. So now let us say, for example, HP wants to use this particular interface and create its own laptop builder. So you can write class HP laptop builder, and this can inherit from iLaptop builder, and inside this class you can declare your constructor method first. So you can write def init, and now you can create a new laptop object. So you can write self.laptop equals to, and you can call the laptop object. So when you are calling the HP laptop builder, the first thing it must do is to create a laptop object. Only if you have the laptop object, then only you can add the specifications to that object, right? So that is the reason why the first thing that we are doing inside this HP laptop builder is to create the laptop object inside the constructor of this particular class. And then now you can simply implement all the methods that are available in the iLaptop builder. So you can write def set screen size, and then you can take screen size as the input here, and then you can write self.laptop.screen size equals to screen size. And what will you return when it comes to builder? So I hope that you answered this in your mind. It was return self. And why is it so? Because you can chain all the methods inside your builder when you are giving different specifications to a particular laptop. So I hope that you remember that from the last example that we saw. So the next method will be set processor, where we will take processor as the input, and we can just update this into the laptop object. So self.laptop, and then we can just give processor, which will be equal to processor. And again we will return self. And finally we will also create a method for storage type, and where we will take storage type as the input, and also we will just update this into the laptop object is equal to storage type. And again we will return self. Again, do not forget, you will have to create the build method as well. So you can write def build, and then you can simply return the self.laptop object here. So this is the builder object for HP brand. So which means that now in all the components that we have created our builder component, then we have created our concrete builder component, and also we have created our product component. Now the only component that is remaining is the director component, right? So let us create the director. So you can write class director, and inside this class you can first declare the constructor method. So this director class will basically take your concrete builder as the input, which means that your brand specific builder that you have created, it will take that as the input. So you can write laptop builder as the input for this particular constructor, and we can simply write self.laptop builder equals to laptop builder. And now let us create the method using which we can set or define the specifications into our laptop object. So we can write def, and we can name this method as set specifications, and where we can pass different specifications that we want to store inside our laptop object. So we can say screen size, processor, and the storage type. And inside this, we can simply call our laptop builder object. And now we can chain all these methods which are inside the laptop builder object, right? So we can write set screen size, and let us just pass the screen size input that we have received in this particular method. And then we can chain this with the next method, which is set processor, and then we can pass the processor inside this, and then we can set storage type, and then we can again pass storage type. And finally, do not forget to call the build method, because the build method will have to return your laptop object. So our director component is also ready now. So basically now you have prepared all the components of your builder pattern. So let us just recap. So first you have created the product component where you have created the class laptop, which is the final object that you want to create, which is nothing but the laptop objects. And then you have created the builder class, which can be used as an interface by different brands, right? So you have imported the ABC module and you have declared the different specifications, or you can say you have declared the different methods of different specifications that you want each brand to specify into their laptops. And then you have created the concrete builders, and each brand can have their own concrete builders using which they can define different specifications for their laptops or for their corresponding laptops. And finally you have the director class, and with your director class what you are doing is you are taking the laptop builder object, and using that laptop builder object you are able to specify different specifications of a particular laptop. So I hope that all these components are clear now. So now let us see how all of this is working. So first we need to create an object of our builder class, which is nothing but the concrete builder class, which is nothing but the brand specific builder class in our example. So first we can write HP laptop builder, and here we can just call HP laptop builder, and we can create an object of that particular class. And now we can create an HP director, and inside this director class we can just pass the HP laptop builder object. So if you remember that our director class basically takes the laptop builder object as the input, and now since you have the access of this laptop builder object, you can basically specify all the specifications. So using this HP director you can set the specifications of each laptop. So you can write laptop, or you can say HP laptop equals, now you can use this director object in order to pass all the specifications of the laptop. So you can use this set specification method as it is showing here. So we are basically calling this particular method, and inside this it will ask for these three parameters, right? So we can simply write these specifications now. So let us say this HP laptop has the screen size of 15 inch. So we can write 15 inch, and then say for example it has Intel i7 processor, and also it has a storage type of SSD. So when you call this particular set specification method in your HP director object, then it will specify all the specifications of this particular laptop into your laptop object. So now after having added all the specifications inside the laptop object, now you can basically print to see the specifications of this particular laptop object, right? So you can write HP laptop dot specification, because remember you have created a specific method in your laptop class to show the output, right, of all the specifications of the laptop. So you can simply call that specification method in order to see the output. So now if we execute this code, and let's pray that I have not created any errors or bugs inside this code. So let us execute this code, and yes, as expected I have created some bug. Let us see what it is. Okay, so it is complaining that none type object has no attribute specification, so which means that nothing is coming here in this HP laptop object, and which would clearly mean that in my specification method I am not returning anything. So we can write return here. So now I think that it should be fine. So let us execute the same code now, and it gives an empty value now. So let us see what we have done. Okay, so in the specification method again it was returning an f string, right? It was not printing the f string. So we can just mention print here so that we can print the returned value of this particular method. So now if we execute this, then as you can see here that we are getting the output. So it says that screen size is 15, which we have passed here, and then the processor is Intel i7, and then the storage type is SSD. So which means that you are able to create a HP laptop by using the HP laptop builder, and this HP laptop builder we have basically created from the laptop builder interface. So which means that you have created a common builder interface using which different brands can create different laptops. So say for example you want to create another laptop in HP brand itself, then what you can do is you can create one more object of your HP laptop builder. So say for example this is 2, and now you can again call your HP director with the second laptop builder, and let us name this HP director as 2. And finally you can create another laptop in the same brand, and let us name this laptop as HP underscore laptop 2, and you can use this particular HP director 2 here in order to call the set specification method. And let us change the values here. So we can say this laptop is 16 inch and this has a different processor. Let us say it has i3 processor, and also it has HDD storage type. So now if you execute this code in order to see the specification of HP laptop 2, then as you can see here that we are also getting the specification for the HP laptop 2 as well, which means that the same brand can create any number of laptops as per their requirement. So now let us say that there is one more brand, say for example Dell brand, which wants to create Dell laptop using the same interface builder that we have created. In order to do that, what you can do is simply you can copy the HP laptop builder, and from that you can create the Dell laptop builder, and let us keep all other details same. There doesn't seems to be any change that are required inside this class. And now in order to create a laptop for Dell, you can write Dell underscore laptop builder, and this time you can use Dell laptop builder, and then you can write Dell director, and in this you can again call the director class, where you can now pass the laptop builder that you have created for Dell, which is Dell laptop builder, and you can pass the object of that particular Dell laptop builder. And now you can create a Dell laptop using this particular builder. So you can say Dell laptop equals, you can use the Dell director now in order to pass all the specifications. So you can say dot set specification, and now we can say, for example, pass the screen size as 14-inch, then we can pass the processor as Intel i5, and again the storage type as, say, for example, SSD. So now if you print the specification of this laptop, then as you can see that you have also created a Dell laptop using the same interface builder. So this is the main advantage of using builder design pattern. It basically allows you to create complex objects, and also you can create different representations of your products. So I hope that now you understand the definition of builder design pattern. So what was the definition? That builder pattern basically allows you to create complex objects in a step-by-step process, and also it allows you to separate or segregate the process of object creation into a separate builder class, and by doing so you can create different representations of your final product using the same object creation process. So I hope that now builder design pattern is absolutely clear to you. If you have any doubts or any queries, do not hesitate to post those queries or doubts in the comment section. I will definitely respond to you. My main intention is to help you understand all these design patterns. Also, if you need any more examples, any more complex examples to understand this particular builder design pattern, then just let me know. You can also mail me. My mail address will be available in the description of this particular video. So if you have any suggestions or feedbacks on this particular video or any other video that I have created, you can definitely post them in the comment section. So I hope that this video really helped you, and also you were able to get a lot of value from this video. So in the next video, we will understand about builder facets. Now we have understood that how we can use builders to create a complex object. But when it comes to builder facets, the problem statement that builder facets addresses is that sometimes your object is so complex that one builder is not enough to create that complex object. Sometimes you will need multiple builders in order to create a complex object, and that's exactly what builder facets helps us to do. So in the next video, we will understand about the builder facets. So I hope that you enjoyed this video. So if you like this video, then hit that like button, share it with other code lovers, and also subscribe to Code Framer for more videos in the future. Thank you, and see you next time.